So if you're a VCE method student, you've definitely got one of these, right? The TI Nspire. But here's a thought. What if it's not just a calculator? Today, we're going to unlock its hidden power. We'll see how it's actually a visual learning machine that can help you really, truly get your head around some complex math. Okay, let's just get right into it. For most people, this thing is for, crunching numbers and checking if you got the right answer. But honestly, that's not even scratching the surface. We're going to start treating this like a secret weapon, something that can bring those abstract ideas right to life, right here on this little screen. So you ready to see what this thing can really do? Come on, let's get started. First up, graphing. And no, we're not just talking about plotting a function and walking away. We're going to tackle transformations and make them feel completely intuitive, maybe for the first time. You've been there, right? You're staring at a function, something like a times x minus b to the power of n plus c. And, you've memorized that a stretches it and b shifts it. But what does that really look like? What does it feel like? It's all a bit abstract. Well, that's about to change. The magic trick here is a feature called sliders. It's so simple. When you type in a function with a letter you haven't defined yet, like the n in x to the n, the calculator just asks, hey, you want to create a slider for that? You say yes, and suddenly that static letter becomes a dynamic dial that you can physically control. And boom, here's the payoff. Just look at this. As you move the sliders for n, a, b, and c, you see the graph literally morph and transform right in front of your eyes. A dilation isn't just a number you multiply by, it's a visual stretch you can see happening. A translation isn't just some instruction, you are physically sliding the graph around. This is an absolute game changer for building that deep, intuitive understanding. Now, what's really cool is this isn't just for the simple stuff. We can apply the exact same idea to way more complex polynomials, especially when they're in factored form. So here, we're setting up sliders for m, n, and p. Those are the powers of each individual factor. All right, so let's watch what happens. As we change these powers, look closely at the x-intercepts. When a power is just 1, the graph cuts right through the axis. Make it 2, and it just kisses the axis, like a parabola. Make it 3, and it flattens out into a point of inflection. You're not just memorizing rules from a textbook anymore, you are seeing them happen. Okay, next up, we're tackling the big one for VC methods, calculus. Let's forget about all the abstract symbols for a second and actually visualize what derivatives and integrals are all about. We'll kick things off with an old classic, the parabola, f of x equals x squared. And our mission, should we choose to accept it, is to figure out the derivative. That's the gradient of the tangent, the instantaneous rate of change, at one specific point on this curve. So, how in the world do you find the gradient at a single point? Well, we start by cheating a little bit. We approximate. We pick any 2 points on the curve and draw a straight line between them. That's called a secant line. And here's the key idea. As you slide those 2 points closer and closer and closer together, the gradient of that secant line gets to be a really, really good guess for the tangent's true gradient. And this is where the Nspire just makes it so easy. We can plot those points, draw the secant lines, and bam, it instantly tells us their gradients. You can see these lines here have gradients of 7 and 13. This whole abstract theory of approximation suddenly becomes this concrete visual thing you can actually play with. Okay, so moving from a good approximation to the exact answer, for that we need this big idea called a limit. The limit is basically the value that our secant line's gradient is getting closer and closer to as the distance between our 2 points gets infinitely close to 0. It's the perfect exact destination of that little animation we just saw. And of course, the calculator has a button for that. There's a dedicated limit function. You can just plug it in and find that precise value, no guesswork needed. You can even tell it to approach from the left or the right side, which is super important for understanding things like continuity. All right, for our last section, we're really going to push the limits. This is where the TI Nspire stops being just a learning tool and becomes this incredibly powerful problem-solving machine that you can actually customize yourself. This is where it gets really, really cool. You can create your own custom tools or widgets. Think about it. Let's say you're always trying to find the area under a curve. Instead of typing in all the commands every single time, you can build a tool where you just pop in the function, pop in the boundaries, and it shows you the answer. You're not just using the calculator anymore, you're building your own little math apps. And if you really want to go deep, this thing is basically a pocket computer. It has a full Python programming environment built right in. Now, why would you need that? Well, for problems that need a ton of repetitive calculations, or for coding your own algorithms from scratch, like Newton's method for finding the roots of really messy equations, this is a massive leap in problem-solving power. So let's just take a step back and appreciate what's possible here. We're talking about everything from high-level stuff like Newton's method, to writing your own programs in Python, and even building interactive pages to solve complex optimization problems. The ceiling on what you can do with this is incredibly high. It's really getting you ready for university-level thinking. So, after all that, what's the big takeaway? It's really this. The true power of this device isn't just about spitting out the right answer. It's about giving you a playground to explore the concepts, to see them, to manipulate them, and to really understand the why behind the math you're learning. And that brings us to the end of this tour. But really, for you, it's just the beginning. So my question to you is, after seeing all this, what's the first math concept you're going to go and bring to life on your calculator? Thanks for tuning in.
Hey, welcome to The Explainer. Today, we're going to look at a tool that kind of flips the script on what a calculator is even for. See, it doesn't just spit out an answer. It's actually designed to help you understand the question in the first place.
I want you to think back to your math classes for a second. For a lot of us, it was all about memorizing formulas from a textbook, right? Static pages. But what if you could actually play with the concepts, see them react in real time, and build your own intuition? Well, today, we're diving into a piece of tech that tries to do exactly that.
So this is it, the TI Nspire CX2C-AS. Now, for high school students, especially those in the VCE program down in Australia, this thing is way more than just a calculator. It's a dynamic tool for digging into really complex ideas and turning abstract math into something you can literally see and touch.
Okay, so how does it actually work? Let's start with a big one, functions. We're going to see how you can take a polynomial from just being a flat equation on a page to becoming this living, breathing curve on a screen.
You know the drill, right? Traditionally, you see an equation for a cubic function, and your first thought is, ugh, I gotta plot points, do a ton of algebra, and then try to sketch it out. The whole process can feel really disconnected from the actual shape you're trying to make.
But check this out. Here, we start visually. Instead of typing in some complicated equation, you just place the function's roots, the points where the curve is going to cross that horizontal x-axis. We've got points A, B, and C. You're basically just telling the calculator, hey, I want my curve to hit the axis in these 3 spots.
And bam, just like that, the calculator generates the perfect cubic function that fits your points. No tedious calculations, nothing. You immediately see the connection between the roots you just dropped on the screen and the overall shape of the curve. You literally just built a function with your fingertips.
And this is where the magic really happens. You can actually grab one of those roots and just drag it along the axis. And as you move it, the entire graph morphs and updates in real time. So you're not just looking at one static example, you're exploring this whole family of functions and getting a real gut feeling for how each root affects the curve.
Okay, so let's take this interactive idea and apply it to something a little more advanced. Calculus. I mean, this can be one of the most abstract, most intimidating topics in all of math. But what if you could actually see what a derivative is doing?
So here's the classic calculus problem, right? You've got a curve, and you want to know its exact steepness, its gradient, at one specific single point. The old school way involves all these complex formulas about limits and derivatives. Well, with the Nspire, you just tell it what you want. It's crazy. After you've defined your function, you just use the command tangent line and tell it the point you're interested in this case, where x equals 1. All that complex theory is boiled down into one simple, intuitive command.
And there you go. That's the result. The calculator doesn't just give you the answer, the equation of the tangent line. No, it draws it for you, showing it perfectly touching the curve at that one single point. This visual makes the whole idea of a tangent line just click. It's instantly clear.
And just like we did with the cubic function, you get to explore. You can move that point of tangency anywhere along the curve. Watch as you approach the bottom of the curve. You see the tangent line flatten out completely until its gradient is 0. Then move it up the other side and you see the gradient turn positive and get steeper and steeper. You are literally watching the derivative change in real time.
All right, for our last stop, let's see how this thing tackles probability. This is where it lets us run simulations that would be absolutely impossible to do by hand, connecting these theoretical ideas to what looks like real-world data.
Seriously, just imagine trying to do this manually. Rolling 2 dice, adding the numbers, writing it down, and doing that 1,000 times.
It would take you hours, and you'd probably mess up a bunch. But the whole point of doing it is to see which sum pops up most often and how that stacks up against what probability theory says should happen.
And what's just nuts is how simple it is on the calculator. The command randin 16 is just like rolling one six-sided die. So you just add two of them together and tell the calculator to do it 1,000 times. That's it. You've replicated the entire experiment with a single line of code.
So in one simulation, the number 7 was the most common sum. It came up 163 times, which is a frequency of 16.3%. Now here's the really cool part. The theoretical probability of rolling a 7 is 1/6, which is about 16.7%. The simulation gets incredibly close. It's just a powerful way to see the theory actually working.
And that's the magic, right there. It takes this abstract idea, theoretical probability, and makes it totally tangible. Students can run the simulation themselves, see the results with their own eyes, and build a way deeper, more intuitive grasp of why the theory actually works.
So when you pull all this together, it becomes pretty clear that this isn't just about getting answers faster. What we're looking at is a fundamental shift in how mathematics can actually be taught and learned.
The big takeaway here is that tools like this completely change the goal of math class. Instead of grinding through the manual labor of calculation, students are free to actually focus on understanding the concepts. They get to ask what if, they get to explore, and they build a genuine intuition for how math works because they're treating it like a subject you investigate, not just memorize.
And as the teacher resource book for this calculator puts it, the goal isn't to be a complete manual that replaces good teaching. It's a powerful aid. It offers suggestions for how to bring every part of the curriculum to life. It's really a tool for teachers to help create those aha moments for their students. Which kind of leaves us with one final thought. If a single handheld device can transform math from this static, intimidating subject into an interactive laboratory, well, it forces us to ask a much bigger question about the future. What other tools are coming? And what will the classroom of tomorrow really be capable of?